All right, Unit 3 review for the test tomorrow. Just a couple reminders as we're going through section to section on these. In this first part, again, note the signs in the middle. You are not multiplying. Do not do monster boxes on these. A, it would take you too much time, and B, it would be wrong. Just go through looking for like terms. So in this first one, the plus, no big deal. I just, again, notice my exponents aren't changing. And I just work my way down from the terms of greatest degree. I didn't have any x to the thirds. And work my way down in degree order until I run out of like terms to put together. I'm done. But again, no messing with exponents when we're adding and subtracting. The only thing I might have to do when I'm getting to problems like this is possibly do a little distributing. For a majority of you, I would highly suggest, just because sometimes we can forget something or get a little sloppy, is literally distribute that negative through, meaning just change the signs on all of these. Then go ahead and put like terms together. So 15 minus 4 would be 11x to the third. Negative 8 plus 7's negative 1. You can put the 1 there if you want to. Negative 11 minus 2 is negative 13, and we're good to go. Okay, keep life simple. And again, on any of these, if you go later, you're like, well, I'm not sure. That's why we've got section numbers in each of these, so you can see, you know, where do I look if I need a little extra help with this. Let f of x equal this polynomial. Find f of negative 4. Again, a couple of options. Most literally, all I need to do is stick negative 4 in every place I see an x. And again, that doesn't mean at the end you go back through that and multiply everything again. Substitute it in. And if you want to just pop that into the calculator, you could. That's probably what I would do in this case. But for time's sake, nothing. Let's go ahead and put it in there just so we don't do something silly. Because the big thing is going to be with these, and for most of you, most of the time, it's detail stuff that tends to drive you crazy. And it drives me crazy too, because then you get wrong answers. And I'm like, but they know what they're doing. Why do they not do it? So let's see here. Make sure I don't get sloppy with anything. And I've got that one and I'm rolling. Now to one of our favorites. We have a story problem. NHS is selling handmade scarves for a fundraiser. The revenue from the sale of X scarves is given by R of X equals 16X. Suppose the function for the cost of manufacturing the scarves is 4.5X plus 120. What are the scarves selling for? Not a fundraiser. Here's my revenue. So it'd be $16 per scarf. So I've got to put a value to that. My profit function, again, is my revenue minus my cost. My revenue, we saw up there, is 16x. My cost, which I would subtract, is going to be the 4.5x plus 120. But again, the critical thing here is the parentheses. Because if those aren't there, I just would be subtracting the 4.5x and then adding the 120, and that could get me into trouble. So I usually will go ahead and distribute that through. If you left it like that, it would be okay, as long as the parentheses are there. So 16x minus 4.5x is 11.5x, but here's the biggie. The negative also goes here. Yes, you could. Yep, you absolutely can. Because to find the profit on 60 scarves, right, no matter if I have it in this form or this form, I'm just going to plug in the 60 where the x is at. So since I went ahead and simplified, I'll just go ahead and pop it in like this. And then I just pull that up. A little quick math here. And I find out we'd make about $570 on doing this one. But again, it's this form, knowing it's revenue minus cost, is going to be your big thing with that. All right, let's see what else we got here. Let f of x and g of x, okay, we have our functions. Write an expression for each function, state any domain restrictions. Again, domain restrictions. Fractions and even roots, if we happen to run into either of them. Otherwise, I don't have to worry about that part. So f plus g of x, again, just means f of x plus g of x. It doesn't mean add them together and then multiply it by x. So I'm just going to take my f of x, 4x squared plus 2x minus 3, and I'm going to add g of x. No need for sign changes or any of that stuff. So when I get here, I go, okay, combine like terms, just like I did up above. 4x squared, 2x and x is 3x, negative 3 and 1 is negative 2, and I'm set. Okay. All this is a label. Don't use that as part of your calculating. Okay. F times g of x. I'm going to multiply these. A lot of you on the organizational front have decided to go this way, which is absolutely fine. If some of you are still more comfortable just distributing it through, that's okay too. Here, once I get it set, I'm multiplying to fill in the box. So we are going to see some changes to exponents on these. So I'll add my exponents when I'm multiplying while I fill in my box. And then again, the nice thing with this is all my like terms are going to be taken care of for me and even in the right order. So I've got a singular x cubed term. Again, once the box is full, no more messing with exponents. We're just combining like terms. So 4 and 2 is 6x squared. 2 minus 3 is negative x. And minus 3. And I'm ready to roll. Again, sorry for my non-filled in dot there on 6. Same concept, except now I want to know, well, what up when the value is negative 5? Now, if I'm confident that I did this last one right, I could just stick negative 5 in for each of those and take the answer. If I'm not quite so sure, my other option would be to go ahead and plug the negative 5 in for each of them separately and then just multiply them together at the end. So like for instance here, if I did that, I'd say, okay, so f of negative 5. So here's my f function. So everywhere that there was an x, I'd go ahead and I'd just plug in negative 5. And I'd get myself a value, make sure I typed everything in right. And then here I'd have negative 5 plus 1, which would be negative 4. See how we're doing over there, and we got the same thing. But I would get the same thing if I just plugged in negative 5 to each of those. It would work out. So it's kind of your own pick, whichever you're more comfortable with. But notice so far we haven't seen even roots. We haven't seen any radicals. We haven't seen any fractions yet. That's about to change. So this last one, couple of things. One, no, I cannot cancel these. Again, they're bound together by the plus and minus. So unless I had something identical to take out, I can't take anything else out of here. The other thing, though, is fraction, I have an issue. My issue is this can't equal 0 because then it's undefined. So my job is to figure out what value would cause that problem. Well, here, if I wanted to get x alone, I'd just minus 1 to the other side. And I don't care if you even write it this way. you're still showing me you get, well, x can't be -1, because if it is, -1 plus 1 would be 0, and that doesn't work. So this is my simplified form of my expression, but I have to have the restriction on that one, because otherwise I have that hole that would be an issue, and I have to be careful of that. And then there's one more sneaking in on this section. Let f of x equal 3x squared minus x. G of x is x minus 7. What is f minus g of 8? Now again, you have options. Some of you may feel more comfortable writing this out and simplifying f minus g and then plugging in the 8. That's okay. Or you could just take the 8 and plug it in right away. So like here, if I plug my 8 in right away, I'd have 3 times 8 squared minus 8. So this would be, my f of 8 would be 184, and then my g of 8 would be 8 minus 7, which is 1, and then it's f minus g. 184 minus 1 is 183. And again, I'd get the same thing if I went ahead, combined those to get 3x squared minus 7, and then just plug that in that way. Again, it's the way that you are most comfortable with. Everybody's got their own thing. And then these last couple in our functions are just a couple of multiplying problems again with a value. So again, simplify the value first. So for instance, we're going to look at p of 3 times q of 3. Well, p of 3, so 3 minus 4 is -1, but be careful, it's absolute value, which means it's going to come out of there positive. So the absolute value of -1 is 1, times 2 is 2. 7 minus 3 is 4. And just multiply them together. Same thing here. I'm going to have q of -4 times p of -4. Well, q of -4 would be 7 minus, be careful, -4. Minus a negative, 7 minus -4 is plus, which would be 11. Plug in a -4 in my p. -4 minus 4 is -8, but it's the absolute value, so it's positive. So 2 times 8 is 16. And then just multiply those together. So basically it's substitution and then follow whatever operation you're being told, whether it's add, subtract, multiply, whatever it happens to be. And if I get rolling along with any of this and you've got a question, shoot, jump right on in. Okay. Inverses. Here, reminder. We're going to switch x and y. And once we do, we're going to solve for y. So I remember that f of x really just means y. So when I'm doing this, when I switch x and y, I'd have x equals -2/3 y. And some of you have different ways you're comfortable doing this. Some of you will go right to a reciprocal on this, and that's fine. Others of you will say, well, I like doing it a part at a time, because otherwise I do get stuck with detail stuff. Okay. If you're going to go a step at a time, you could multiply by the 3 first. And then go ahead and divide by the -2. And like I've said before, you could write it as 3x over -2 if you went that way. If some of you went reciprocal-wise, you'd have -3/2 x. That's fine. They both mean the same thing. As long as you get y by itself, you're good. But that's the process that we're going to work through. So it's always, always, always oops, switch x and y, work on isolating that y term first. I'll get it out. Thank you. Now, since on the last one we did it piece by piece, this time I'll do it for our reciprocal fans. If I want to get rid of 7/2, I'll just multiply both sides by 2/7. On this side, that'll get y by itself. And on the other side, I do want to distribute that through. So when I distribute it through, I get 2/7 x. And then don't panic on the fraction part. This is going to come out nice. Take your 2, times it by the 14, which would be 28, and then divide by the 7, which is 4. And I suppose you could even do it as 2/7 times 14 on the calculator. That'd work too. Y is by itself. I've got my expression. I'm ready to roll. But if you get fractions, I just don't want to see divide by a fraction, because people don't know what that means, and that just kind of makes it hard. Okay, 2 examples of functions whose inverses are functions. Remember, they have to pass the horizontal line test in order for an inverse to be a function. So what's an example of something I might be able to draw that would pass the horizontal line test? Okay, any particular direction? Okay, now if I did a parabola that was facing downward, if I draw a horizontal line through, is it going to pass the horizontal line test? No. Now, that doesn't mean the parabola won't work. What direction would I need it to be going? That'll work for what we're going to do next here. But yeah, if you had a parabola that was turned to the side, that would pass my horizontal line test. That would work okay. I heard another option out there as we were doing it saying, well, can't you just draw like a line? Sure. Because again, if I were to draw a line through there, it only crosses at one place. That's the types of things that we're trying to look for right now. Because again, we're looking for inverses that are functions to make this work. So those 2 would work. Those would be a couple of examples that would work out okay. Then our favorite section, factoring. Big star. Our golden rule. Always look on every problem. Is there something I can take out before I even start? Because I'll admit it, this first one is tricky. Because those of you that do know your cubes, you're like, ooh, they're both perfect cubes. 2 cubed is 8, 6 cubed is 216. But there's a small problem. 8 also divides into both of those. Yeah, because if I try to do 216 divided by 8, it goes in. It's 27. So I would take the 8 out, and I'd be left with x cubed plus 27. That's not going to change the fact that I can break this down still, because just because I can take out a common factor doesn't mean every single time that's all I'm going to be able to do. Again, your cubes, and you've got to know your pattern for this one. And again, even on the YouTube page, I've got playlists by unit. There's everything from Unit 3 is in its own little playlist, and it's always got section numbers, so you can always go back and look that way too. Whatever I cube to get each piece of this is what I'm going to use in my pattern. So I'm going to keep that 8 kind of to the outside here. And I go, okay, well, I know in the first set of parentheses it's just whatever I cube. And I use the sign that I used up above. But then what do I do? And yeah, I'm going to do some squaring here. So right, I'm going to square my first term. And that was a good thing you mentioned right away. Switch the sign. If this would have started as minus, this would become plus, and vice versa. But they'll always be opposites. Multiply my two terms together, and then plus the square of my last term. And this will always be plus. Why? Because if I'm going to put it in the calculator, I'm going to use parentheses. That's going to keep me from getting that negative number at the end. Nice thing about cubes, they never break down again. Once you break it down, it's done. And it's nice.
Could you go right off the bat and just like do it the regular way by going like 2x plus 6?
You can, but if you go right away with the 2 and the 6, when you get to the end, you would need to pull the common factor out still. It would still multiply outright, but when we've talked about it before, it's sort of the equivalent of if you write down your answer to a question as 3/6, and we know it's a half, it's not quite reduced completely. So it's just one of those things you always want to be watching for that. Now in this next one, hopefully, you don't get spooked by the 4. Square, square. Oh, it's like a difference of squares. Okay. Because if some of you saw something that looked like this, you wouldn't panic at all. You'd be like, if you saw this, you'd be like, oh, that's not a big deal. It's 4x, 7, 7 plus minus, and you'd be fine. But some of you panic when you see the 4th. You're like, there's got to be some other weird thing I'm doing. Not really. X times x is x squared, but I don't have x squared this time. X squared times x squared equals x to the 4th. And just because I have a y here, we just squeeze that in the end. And everything works out that way. So if you have to on something like that, if you see something to the 4th, just write it as a squared for a minute, get your basics down, and then go back and say, oh yeah, 2 and 2 would get me to 4. Okay, it's just a little bit different looking. So no panic needed there. If you see 4 terms, pair them off. Find the greatest thing that each pair has in common. Here, 2 and 3, nothing in common. Variables, though, I have x's, and I always take the one with the smallest exponent. And then I see what I got left over. 2 and 1 get me to 3. Here, I've already got the x squared, but I need the 3. So we're kind of doing reverse distributive property. But then you get to the next one, you're like, 2 and 3, nothing really goes in. Okay, but I always got to pull out at least a 1. Any other suggestions on this one besides pulling 1? Negative 1. If they're both negative, I'm going to go ahead and I'll pull the negative with. Because remember, when I do these, what I get in the parentheses should be the same at the end. So here, I do 2, because negative 1 times 2 is negative 2. X plus 3, because negative times positive is negative. And normally then, I just put my greatest common factors together, what I had outside the parentheses. I put one of these in there, and normally I would circle this and be done. But I'm always going to double check for something. Ooh. Perfect square. Perfect square. I can break this down again because it's minus, because it's a difference. So this time, x times x is x squared. 1 times 1 is 1, and it's plus minus, but I just don't touch the third one. So you're like, well, what if I just got to that step before and this was like the test? This is probably a 2-point question. You get like 1/2 of 2 off. So it's not going to be monstrous, but look for those little things, because those are the things that can tend to get you. And again, if I throw another one on here, look for what they have in common. Whatever's left, put it inside. I look this time and I'm like, oh, well, those are going to be the same already, so it's going to be a +1 this time. Because again, always make sure if your parentheses aren't identical, something's not going right with what you're pulling out, and that's going to be your hint. And to try and save some of you pain here as well, going into over-factoring craziness, there's no such thing as a sum of squares. Sum of cubes, yes. Sum of squares, no, because it wouldn't multiply outright. So that one's just going to get left alone. Don't freak out with the 4. It's a diamond problem. When I get to this, sort of like what I talked about before, look at this like it's x squared minus 12x plus 27. Most of you can fly through those at this point. What multiplies to positive 27 and adds to negative 12? Yeah, I know they're both going to be negative because they multiply to a positive and add to a negative. 9 and 3. And since it's x to the 4th, I just like before, like I did up here, I just have squareds. But once I do that, the question becomes, am I done? Can I do anything with either of those, or am I just done? Difference of squares. And again, that's why when I kept harping before about gotta know your squares, gotta know your squares, gotta know your squares. This is why. So when you see something pop up like these, immediately your brain starts going, wait a minute, square and square. I think I can break that down again. And you remember to. Excellent if you can get here, best if you can get to this one. But again, you'll notice on a lot of these, there's something to take out, something to take out, something to take out. Here, again, don't let the 5 get you. What's the biggest thing I can take out on 19?
3.
Nice. I can take a 3 and I can get an x cubed because that's the smallest exponent term that I have. Because once I do that, life is going to be much easier. 3 plus what gets me to 5? X squared. Minus 8. 3 to get to 4, I need 1. 3 to get to 36 is 12, and I already have all the x's that I need. So after doing all that, now all I have to do is see if I can factor what's left with a diamond. What do I know here? Let's see. I know if they multiply to a positive and add to a negative, they're both negative. So multiply to 12 and add to 8. 6 and 2. And I'm in business. And then now that I got you thinking every single one of these is going to take something out, well, now we'll look at one where they don't have anything in common right away, but, ooh, I see cubed. I see cubed. Whatever I cube, whatever I take to the 3rd power to get each, and remember, if you don't remember if it's a cube or you're not sure, you can always take a number to the 1/3 power and it will get it back for you. So like if you were looking at 125, you're like, you can always do 125 to the 1/3 power in your calculator, or any number to the 1/3, and if it's a perfect cube, the cube will come out like this. So that lets me know, and again, I'm looking at this like it's a 5. I'm not using the negative with my 5. Because then when I go to factor it, I use the 2x and the 5. I look at the original problem to get my first sign, the minus in this case. Then when I move to the second part, I go, okay, square the first term, the 2 and the x. Don't put 2x squared. The 2 also has to get squared. Change the sign, so now it becomes plus. Multiply those together, and now you see why I don't want the negative with my 5, because I might want to put negative 10x then. That won't be a good idea. And then square my last term. And I'm good. But again, if 6-4 is your thing, go back to the video, go back to the book section, do something with that to make it a little bit easier. Explain how to identify an expression as a factor of a polynomial. Either one of these would be fine. If you're doing synthetic division, what should you get for a remainder if it's a factor? when we were doing the synthetic division, if you got a remainder of 0, those were our solutions. Those were our answers. So that's one way I could say it. Or if I'm graphing, my x-intercepts are part of my factors or my solutions. Either one of those are fine. If you want to put both, hey, whatever works for you. Okay, but either of those would work. If I have a 0 that's an I, we talked about this before. If I have one I also have to have its complex conjugate, its opposite. So if 5i is one of my answers, or zeros, negative 5i is. If negative 3i were one of my answers, positive 3i would be the other one. So those two, you're always going to get the plus minus on both. I had a couple people ask on 23, well, do I have to use long division and do x minus 3? No, but if you're going to use synthetic on this, that's not saying x equals negative 3 like we're going to see in some other places. If you use the binomial and go to synthetic, make sure you solve for x and you change the sign. Or you can do long, because you got to do long on one of the other problems anyway. But if you do synthetic and it's a binomial, change the sign, because otherwise it won't work. Oh, what evil thing did I almost forget just now? Yeah, it goes from 3 to 1. I can't do that. There's a 0x squared in there. So it's 2, 0. Don't forget about that. Ooh. It's 0. If I'm missing a degree, it's a 0. So drop down my 2, multiply them, add down. Multiply them, add down, multiply them, add down. Now it doesn't mean if I do regular division like this, oh, I didn't get a remainder of 0, it's wrong. It didn't say that this was a factor, it just said divide it. So once I go ahead and divide it, you know, I'm careful, make sure I don't do something silly. I look at the degree I started with, I look at the 3, and I start one lower than that. So 2, 1, 0, and then my remainder, I don't just put R47. Whatever I divided by, whatever this is just going to go at the bottom. And that would be my division on that one. And it would look exactly the same whether I did the synthetic with the 3 or I did the long division with the x minus 3. Okay. All right, let's see what else we got here. All right, graph of the function. Here's basically what I would look for, just to make sure you're a little bit looking good on this one. And there may have to be an extended part of this that I finish once you guys are gone, because I am working through here, not wanting to rush, but at the same time. All right, there we go. So when I graph this, I still want to make sure I get as many values in that I can. I know right away, though, that at -4 and at 1, I'm going to have points that I can use. I also notice with this graph, just looking in there, I've got at 0, 4, I've got a point I can use. 2, okay, the 6 is a little off the screen, but it's not like over the top crazy. But the other ones aren't really, there's not a whole lot else there for me. So when I look at the graph, I'm like, okay, I can make this work. So I'm going, and I'm like, okay, yep. Oh, it just kicks that because it's a bouncer. Not perfection, but it looks pretty close to what I had working there is what I'm going to be looking for. So I'm like, okay, this ain't going bad. I'm just sort of floating my way along here. Oh, what else we got? Synthetic division. We just got done talking about this a minute ago. When you're doing synthetic, change signs here. it'll be working with 4. I think I can get both the divisions done here. So 4, negative 10. Oh, watch out. There's a 0 here too, because I have no 0x term. So 4 times 4 is 16, which is 6 times 4 is 24. Ooh, this is going to be a big number. 96 is 98. And again, doesn't say anything about a factor. That my remainder isn't 0. That's okay. My degree, start 1 below it. And if I do have a remainder, I'm going to divide through by that x minus 4. And then several of yours favorite will be either the next to last or the last one that I do right here for now. But like I said, this will be finished with the online. I always put plus, and if the remainder happens to be a negative, I'll just keep the negative on there, because that way I'm doing the same thing every time. That's a good question. Long division, I'm going to use everything I've got here. No holes this time at least. That's nice. So remember, there's going to be side work on this one. And it's always the first term that I'm dividing by, divided by the first term out here. First term divided by first term. Whatever that happens to be, that'll go up here, because that's part of my answer. And then I take that solution, the second part, is to distribute that through my divisor. So 6x cubed minus 3x squared. And that's what's going to go underneath here. But here comes the kicker. This is the kick in the pants. It always seems to get everybody. Remember, you're subtracting. This isn't synthetic division. 6x cubed minus 6x cubed. Okay, that part's good. It's supposed to be. Don't do 7 minus 3. 7 minus negative 3. Like 7 plus 3. So it's 10x squared minus x minus 2. And the process starts over again. First divided by first. Ten divided by 2 is 5x. Take that 5x, distribute through. Again, be careful on the subtracting. Negative 1 minus negative 5 would be negative 1 plus 5, which is 4x minus 2. And I've got to do this one last time. I'm going to squeeze it over here. So 4x divided by 2x is 2. And distribute that 2 through, which would be 4x minus 2, which cancels out everything and gets me to the answer. I'm going to do one. Moving on, we are also going to be taking a peek here at finding roots. Now again, easiest way to get started on a question like this is going to be to go ahead, bust out the calculator, and go ahead and let our calculator help us find as many of the roots as possible. When we look at this, we see, okay, probably only going to get lucky and get 1. It looks like it's at negative 3. Let's see. Yep, there it is. So I've got 1. That's all I've got, which means my last 2 I'm going to have to find using synthetic division and maybe factoring into the quadratic formula. So I go ahead, get my negative 3 in here. Got my 1. 7, no holes. Thankful for that. So 1, multiply, subtract, multiply, subtract, multiply, and subtract. And since that was supposed to be a factor, I did need to make sure that I had a remainder of 0 on this one. So once I get there, get my values back in. If I tried to factor this, unfortunately, I would find out it doesn't work for me. So I got to go back to my old faithful companion, the quadratic formula, to try and help me out. So, again, my quadratic formula, negative b plus or minus the square root of b squared. Always put your b squared in parentheses, even if it's positive, it's a good habit. Minus 4ac all over 2a. All right, let's see here. So we've got 16 minus 28 over 2. Keep it going. Square root of negative 12 over 2. Okay, here is the moment of truth. We are trying to figure out here. Oh, I see one thing I need. Negative. Pull out an I. So when I pull out an I, this is I square root of 12. But I know I can break the 12 down. We've been doing this long enough at this point, because 12 is just 4 times 3. So the square root of 4 would be 2i square root of 3 over 2. And one last little thing, and again, this is my experts coming in here. If you left it like this, you're going to get a little ding. Because, oh yeah, all 3 of these terms, not under the radical, but all 3 of these are divisible by 2. Oh, no, it's not time to leave quite yet. And again, I could put the over 1, but I really don't need to. So there's 1 answer, 2 answers, 3 answers, 3 answers. I'm good. State the number of complex, imaginary solutions to this equation. Okay. So I go ahead, turn this on, get my new expression in here. And as I've stated before, this is one of those tests that you need to have some expertise coming in. You're not going to have the flexibility to sit and ponder and ponder and ponder with this. It's going to be, you kind of need to know what's going on. So now here I notice, with 4, I know there should be 4 answers. There should be 4 solutions. I can physically see 2, which means I have 2 real solutions. So if there's 4 answers and 2 of them are real, how many of them are imaginary? 2. Okay? Simple as that. Finally, we head to the back here. Find all zeros again. Clear this out. So what I'm trying to say as far as your preparation for this, hopefully if you're home and watching this right now, you're already doing a very good thing. But if there are some parts you're like, wow, that takes me forever, know that on the other parts you've got to make up for it then. So here, 3 answers. Ooh, I see 3 sections there. I think we're going to get lucky. I see 1 answer. Negative 1. Oops, I see. Oh, there the other 2 are. Negative 1, 3, 5. Love the graphing calc. Okay, done with that one. Write an equation with least coefficient that has those zeros. Okay, we've done this. Basically, I'm going to make 3 sets of parentheses, 3 binomial terms, and I'm going to use opposites on each of these. You're like, now why are those opposites again? Because if I were to find the zeros, I'd be setting each of these sets of parentheses, each of these binomials, whoops, equal to 0. So if I set that equal to 0, I'd get x equals 4. Set that equal to 0 and subtract 2, I get negative 2. Add 5, I get this. And then I'm just going to take them a pair at a time. It's sort of like they say on TV with shows sometimes. To save time, I'm going to do the foiling for you on this first one. If some of you are doing boxes on that, that's fine. Because when you get to this point, once you've foiled or boxed this out, I am going to highly suggest for a majority of you that we get ourselves a box for this last part. And we're multiplying to fill in the box. And then again, we're just combining like terms. No more changing of, ooh, excuse me. Not a lot more changing of exponents. We're just combining like terms, and that's it. We're done. And then the last one's what we've been playing with for the past couple of days here. So one more play with the graphing calculator, and then you'll be done. You can kind of let yourself know, what do I need to be working on. Hopefully, you've been kind of playing with this for the past couple of days so you have an idea of what it is you need to be working on. So you're not sitting there going, ooh, I guess I had a little more work to work on here than I thought I did. Okay, let's see what we got going here. Well, before we even get started, let's do the stuff that's easy. My degree is 4. My lead coefficient is 1. All right, let's check the graph out here. Oh, 4, 1, 2, 3, 4. Okay, let's see if we get lucky. I see these zeros we got here. I see one at 0. Oh, no. That might be the only one we're getting. Oh, it is. We're going to have to find the rest. Okay, so I know I have this one already. Well, where are these other ones at? Remember, second, trace, or if you've done something with one of those calculators I've talked about on my website, you might have these done already. I don't know. So we want a 0. Doesn't matter which one we go get first. Normally I'll go get the ones over here to the left. Now notice, watch my y values. They're still going down. They'll start coming back up here in a minute. Yep, here they come. When it starts getting back towards, oops, I don't see that real well, do I? And you're like, well, wait a minute. What are you going to do here? Well, I can do a couple of things. Maybe I take my window and I say, you know what? When I was looking at my table before, look at how big those values are getting. So maybe my window to see my y's better, maybe I just make it bigger. Oh, now I can kind of see what's going on here a little better. Okay, so now I can go look for that 0. So I'm working my way over, Okay, so if I'm starting at the very left, because we always work left to right, I'm here at the left, anywhere above would work okay for me. And so would anywhere below. So I see one of my zeros is at negative 7.20, because 197 would round up. So I do another 0. And I go, okay, looks like over here it's below and then it gets above right in here. So since I'm coming up on it from underneath, I'll click once under. Once I'm above, well, how can I tell I'm above? Right here. Again, watch the y values. It's positive now, so I'm above. So negative 2.12. I already know of the one at 0. You're like, well, Harty, I can't see this anymore. Well, remember, once I'm there, if I want to, I can always go back to standard. And that's why we keep saying with the calculators to play with them more, not just watch everything I'm doing, but actually play. Because now, when I go to find that last 0, I'm below, I'm above, and I got them all. Okay, find the ordered pair for the maximums. Okay, this is where I'd probably, with my window, I'd go back to that funky one we had before, because I could really see everything really well on that. And the table gives me all this really good information. We've talked about that before. So it looks like I got a min here, maybe a max in here. So let's find that min. Let's So again, I'm trying to trap this point down here somewhere. So anywhere to the left of it would be good. Anywhere to the right of it would be good. So I have a minimum at negative 5.57, negative 215.45. Holy moly. But then you're like, ooh, that's kind of squished in. Okay, let's get it back to where it was. You're like, yeah, but now I can't see what's going on way up here. Okay, again, you've got to be able to take your information. Maybe to find my max, I need to go up to 100. Okay, there's my max. I can see it now. I mean, it can take a little bit of, y'all play and experiment with things. You experiment trying to get around things with your folks. This is nothing different. Okay, to the left of it, I'm good. To the right of it, I'm good. Okay, there's my max. Negative 1.19, 16.57. Get my zoom back to normal. Okay. I can see that last minimum down there, so let's do it. Okay, I'm to the left, enter. I'm to the right, enter, and it's down there. You can barely even see it down here. So I got one more min at 0.76, negative 9.62. Okay, I got my mins and maxes done. Now it's increasing, decreasing. So again, I'd change my window because I want to see the whole graph with this. Now, do I have to draw it? No. Okay, where's the function increasing? Well, let's start with decreasing this time because it starts over here. So negative infinity. And remember here, and I'm going to circle them. I'm just looking at my x values with my mins and my maxes to help me. It decreases until I get to my first minimum. My first minimum, negative 5.57. So then once it hits that minimum, it's going to start going back up. So it starts there, goes up until I get to my next maximum. See, this is where having the values helps me. I don't even need to be able to play with it on the calculator. Once I know these values and just how it works in general, there's a flow to it. So it increases until it gets to this negative 1.19. Well, then it starts to go back down again from that same point. Notice I just keep using these numbers. So, oh, lost my graph. So then it starts to come back down again until I hit what? My next minimum at 0.76. And then it stops. And then finally, it says, oh, once I hit 0.76, it's all up from there. So again, you've just got to play when it comes to this stuff. End behavior. You're like, oh my God, we got to go back to that? Yeah. Because remember, we have one x that goes to negative infinity, one that goes to positive, and we're just figuring out what's happening to y. Okay, so as x keeps going to the left, what's happening to y? It's going up. Up's positive infinity. As my graph goes to the right, what's happening to y? It's going up off to infinity. And then the final two questions are domain and range. Domain, we've said, is always the same. Range is bottom to top. Where is my most minimum y value? Minimum y value. Negative 215.45, and then it goes up forever. Now again, you might be noticing at the bottom of the screen, holy cow, Harty, this took you over 54 minutes. We only have 47 in a class period. But again, I was also stopping. I answered a few questions in the middle. I was being very specific and going over things, and it can be done this way, it can be done this way. When you're on it with things, when I initially did this review, it took me somewhere in the realm of 16 to 17 minutes to finish. So this is doable, but again, you have to be on it, and if you get stuck on something, go back, come back to it later, okay? I'm sure you're going to do great. Again, use the section numbers on these if you're having trouble to go back to those sections. Watch videos, try a couple extra problems out of the book or one of the homeworks or something like that, and just give yourself the best opportunity to be successful on the test.